Hello everyone. In this video we'll discuss the today's LeetCode problem, that is the maximum unit on the truck. Okay. So what we are given? We are given a bus. Okay. We are given a bus and we are given the boxes. Okay. Boxes of a particular type. So I will read out the question. You are assigned to put some boxes onto a truck. So this is a truck and there are some boxes that need to be kept inside the bus. So the we are given a 2D array named box types in which the particular element has two further elements that represent the number of boxes and the number of unit per boxes. Okay, so if we see what the question is saying, we are given a 2D matrix and in this matrix there is a box of a particular type. So if I take one of the possible test case from here, so it is 1 3 2 2 3 1. So this is a box of type, let's suppose A, it is a type B box, it is a type C box. Okay, so different type of boxes are given and the first element of the inner vector represent the number of boxes of particular type, and this represent for a particular box of a particular type the number of units in that particular box. So if there is one box of type A, this represents the number of boxes and this represents the number of units inside the boxes. So if we are considering B, we have two boxes that have two units. And if we consider C, we have three boxes that just have one unit. Okay, this is what the question is saying. I have specified you in the easier format. Okay, now you are given the truck size. You are also given the truck size, which is equals to the maximum number of boxes that can be kept. So the truck size represent that you can kept these number of boxes. So these represent the number of boxes, and these boxes need to be kept inside the truck, and the truck size is given. It is as simple as that. I will insist you to first solve the question yourself. Okay. Now you can choose any boxes to be filled inside the truck. Just what you have to do, you have to maximize the number of units that can be kept inside the truck. So the number of boxes that can be kept for this test case will be 4. So we can kept any 4 boxes from the given choices. We can kept it, but we have to maximize the number of units. So if we kept these 1, 2, 3, and 4, if we kept these boxes, the number of units will be, if we kept this, and this, the number of boxes that are kept inside the truck is r equals to 5, r equals to 4, but the number of units will be 1, 2, 3, 4, 5. So it does not give us the maximum number of units that can be kept inside the truck. But if we analyze this, if we kept this box, and this box, and this box. If we kept these boxes, the number of units will be 3 plus 2 plus 2 plus 1, that is equals to 8. We have satisfied the condition that we have to put 4 boxes inside the truck, and we also have the maximum number of units that can be kept. So it's till this point it would be clear to you what you have to do in the question. So we have to just maximize the number of units. So what we can do, simply the algorithm will be clear to you. It is more and more clear. I have explained you the question the easier way it can be. Okay, I insist you to solve this question by your own first, then we'll go forward and discuss the various approaches to solve the problem. Okay, so what we can do, first thing, we can sort the 2D array. Approach 1. Okay, we can sort the 2D array based upon the number of units. So if this is the array which we are given, let us analyze the test case: 5, 10, 2, 5, 4, 7, 3, 9, and the truck size that is specified to us is 10. So if we sort this array based upon the unit in a particular box, so we have this 10 unit, then we have 9, we have 7, we have 5. So after sorting, it would be something like 5, 10, 3, 9, 4, 7, and 2, 5. Okay, we have sorted the 2D array based upon the number of units that are present in a particular box. Now our truck size is 10. We have to keep 10 boxes. So we iterate this 2D array from this side, and we'll check, are the number of boxes here less than the total size? If these are less than the truck size, if this number of boxes are less than the truck size, we can kept all these boxes inside the truck. So now the number of units we are maintaining in a variable name answer. Initially it would be 0. For this we will get 50 as the number of units, because we can kept all these boxes inside, all these 5 boxes inside the truck. So there's a space for 10, we have kept the 5. Now the space is left for the 5. Total size now will be 5. And now we'll move to the next box, because we have kept this particular box inside the truck and we have the total units as 50. Now for this we can check if the number of boxes are 3, the total space is 5. So we can kept all these boxes inside the truck. So we'll kept these 3 boxes inside the truck and we'll get the number of units as 27. So we'll add it into our answer. Simply we add it into our answer, and then now the space that is left inside the truck is 2, because we have filled this. The total space is 2, and we have kept this one also inside the truck. Now for this element, the number of boxes are 4. So we have 4 boxes and the space we have is of 2. So we can kept 2 boxes from it. So what we can do, we can easily say that we can kept 2 boxes. So 2 into 7, we have 14 units. So the total sum would be 91. The total units inside the truck would be 91. Is it set so? Yes, it is the case. Now I have shown you the algorithm. So I will write the pseudocode for it. Okay, I will write the pseudocode for it. So we'll sort the 2D array based upon the units. So we have to use the comparator operator here. So how will we use the comparator operator? So we are having the inner single vector, single 1D vector. We'll pass it by reference, and if you don't know how to write the comparator operator, I would be making a separate video for it, how to write the comparator operator for a particular sorting algorithm. So if we have to make the 2D array sort based upon the decreasing order of the units. So what we'll do for the decreasing order, we'll do this particular thing. If a of 1, that means for the number of units that are greater for this position should be greater than the next position, and this will return true, otherwise will return false. I will make a separate video of how to write a comparator operator. It would be easy for you. Okay, this is the case. And now what we simply do, we simply we'll iterate over the 2D matrix, and we'll calculate Let's suppose we'll calculate the number of boxes and the number of units. We have calculated these two. If the number of boxes that are to be kept is less than the total size, we can easily keep that. We'll increase our answer. Initially our answer would be 0. We can increase our answer by x into y. Simply we can do that, and we can decrease the truck size by x, because we have kept x number of boxes inside the truck. Else what will be the case? We will increase our answer by total size into y, and we'll make our total size as 0. And this condition, we don't use a for range loop here. What we will use? We'll use a simple loop here. So for int I equals to 0 to I less than n, and we have to specify the condition total size not equals to 0. And the case where the total size become equals to 0, that particularly means we'll break this loop. Okay. At the end, what we will do? We'll return the answer. So this is the first approach to solve the problem. Now I'm going to tell you the time complexity for this case. So the time complexity for this case will be n log n, where n is the size of the 2D matrix. In the space complexity should be constant space. Now this time complexity is not bad, but we have to further optimize it. Okay, if the interviewer will ask you to further optimize it, you will definitely do it. So you will think for the way in which we don't have to do sorting. Okay, we don't have to do sorting. So if we don't have to do sorting, what can we do? We have to think that way. Okay, what can we do? So we want the units to be in the decreasing order. So we can think of something like we have the maximum units at the first place. We then have the second maximum. Then we have the third maximum. In that way, we have to think. So we can think of a data structure something like max heap. Okay, a max heap. So what is a max heap? A max is something like a stack. It performs operation just like the stack, but the top element inside the max heap is the maximum element among the elements that are inside the max heap. So if we have a max heap of 10, 20, 30, 40, so this 40 would be at the top of the max heap. We does not know the arrangement of these elements. So if you have studied about the heapify function, so this heapify function will give us the maximum among these elements that are stored in the max heap as the top of the max heap. Okay, so we try to formulate something related to it. So what we can do, we can put the elements of the 2D matrix based upon the units on the max heap. So show you what I am talking about. So this is our default test case. That is the second test case we will be analyzing. So we have a max heap. Okay, we can definitely make a max heap. Now what can we do? We have to iterate over this 2D array and put all the elements based upon the units. Okay, so we'll iterate over this array. I will write the pseudocode for it. We'll iterate because we will be needing all the elements, so we'll use a for range loop. Okay, so for every element present in the 2D matrix, we will push them into the max heap, and based upon the units. Okay, we'll push based upon the units. So this will represent the based upon the units. And one thing, if we store a pair in the max heap, so the values are arranged based upon the first value. Okay, values are arranged based upon the first value. If we are using a max heap, then the maximum among this first value would be at the top. It is not based upon the second value. Okay, for the default case it would be based on the first value. So we'll push it. This is the operation we will perform. So now the max heap will contain something like this. So we have 10 as the maximum unit. We will have 10, 5, then we have 9, 3, then we have 7, 4, then we have 5, 2. Okay. This arrangement can vary, but the top would be the maximum number of units. So we can check. We'll iterate over this max heap. We'll iterate over this max heap and check. The total size is 10. We'll check. For the total size, we'll look up to this second parameter. So if this 5 is less than 10, yes it is, we can store all these 5 boxes into our bus. So we'll have number of units is 50 and we'll pop this element from this. Now the top would be the maximum among these units. So it would be 9, and the number of boxes that can be kept now in the bus are 5. So there's a space for 5. We have 3. We can easily keep them. So number of units now become 50 plus 27, that are equal to 77. And then now the space is left for 2, and we'll pop this element from the maxi. Now the number of elements that can be kept are 2, and we have 4 elements. So we can select 2 elements from it. So the number of units here will become 14. 2 into 7, that is 14. It will become equals to 91, and we can keep 2 units, and here the total size becomes 0, and the place where the total size, or we can say the truck size, become equals to 0, we can stop this loop and we return the answer. So I will write the pseudocode for it, and the time we analyze the algorithm. So first of all, I have written how we'll put the elements in the max heap. Now we will iterate over the loop over the max heap. So while max heap dot size become is greater than 0, and t size, that is the truck size, is greater than 0, we will continue in the loop. Okay, so we'll calculate the top. We are only going to access the top, and the first element will be the unit. So I will name it as u. Okay, name it as u, and we have the second value as the number of boxes. I will name it as b. So this will be the second parameter. So if b is less than the truck size, so we can easily add the number of boxes into the number of units into our answer. So we can easily add it to our answer, and the truck size will become equals to truck size minus the number of boxes we have kept inside the truck. Else what we will do? Else answer plus is equals to truck size into the case we are doing in the approach one. Okay, truck size into the number of units, and our truck size become equals to 0. And here the loop will get over after the truck size become equal. This condition reach here, the loop will get over. At the end, we will return the answer. This is the second approach to solve the problem. This requires us the time complexity of order of n, where n is the size of the 2D matrix. But it also requires us a space complexity of big O of n in the worst case. In the worst case, we will require in all the cases, because in all the cases, all the 1D vector would be in the max heap. Okay. Now, can you further optimize it? Because the thing that is troubling me here is the space. The time complexity is pretty good for this question. Okay, but the thing that is troubling me here is the space complexity. So can we further optimize it? We'll look at the constraints. We will look at the constraint of this question. We'll look at the constraint of the question. We have the box type, box length as it is between the range of 1 and 1000. So we can have only the 1000 box types. So we can have only the 1000 box types. So we can maintain a single 1D vector. We can maintain a single 1D vector where the value represents the number of units. The value represent the number of units, and the index represents the number of boxes. So what I am trying to say here is, for a particular box type, we will maintain we'll maintain we'll store so the index. So what we can do, we have maintained the 2D matrix. Now the index here represents the index, these are in increasing order, so index here represents the number of units. Okay, and the value that is the particular index represent the number of boxes. So what I am trying to say here, let us analyze it using the test case. Using the test case, we have the test cases 5, 10, 2, 5, 4, 7, 3, 9. 4739. It would be easier for you. Okay, now we have maintained a vector, or we can say a single 1D vector of size 1000, or we can say 1001, because it is inclusive. Okay, so here we iterate over the array, and at this index, at the 10th index, we have the number of boxes as 5. At the 5th index, it would be something here, we have the value as, so I will make a longer array. At the 5th index, we have number of boxes as 2. So here it represents the number of index. The 7 here represents the number of units, and the number of boxes of that particular number of boxes are 4, and the number of units here are 9, and the number of boxes are 3. So we'll start iterating from the back side. So from the back side, we can get the maximum number of units. So we can check the total size is 10. Is the value here, initially all the values will be -1. So all the default value will be -1. So if the value is -1, we'll continue to the next value. Okay. So here we'll get a a value that is not equals to -1. We have the value as 5. Is this 5 less than 10? Yes, it is less than 10. Then what we'll do, we'll multiply 5 and 10 and store it into our answer, and decrease the truck size by 5. Now the truck size become 5. We'll move to the next value. It is equals to -1. No, it is not. So we'll analyze it. We'll analyze the truck, the box, number of boxes. The number of boxes are 3. The size is 5. So we can easily kept it. So we can easily maintain 3 into 9 and plus it into our answer, 27. Now, again we decrease the truck size by 3, it will become 2. Is this value at this index is -1? No, it is not. So we'll analyze it. Is the number of boxes less than 2? No, they are not. So we'll take the remaining number of boxes and multiply it with the units. So we'll multiply 2 into 7 and we'll get value as 14 here, and the total value will become 91. So this approach takes the time complexity of order of n, and the space complexity of, you will be shocked that it will take a constant space, because the auxiliary space here which we are using does not changes with the value of n. If it does not changes with the value of n, it is does not included in our space complexity. Okay, we are taking a constant space here. So I will write the pseudocode for it. So what we will do, we will iterate over the 2D matrix. We'll maintain a vector of value that will have vector of int named value, uh, vector of int named value of size 1001, and it will have the default value as -1. We'll iterate over the 2D matrix, and what we'll do, we'll check the value. We'll store the value. Okay, we'll store the value, and the index represent the units. So we'll have p of 1 equals to p of 0. This is what we will do. Okay, this is what we will do. And if there will be the condition, if the number of unit for the boxes will be equal number of units for a boxes. Let's suppose there is a box, number of boxes are 4, the number of units are 5, and the number of boxes are 2, and the number of units are 5. So we'll add the number of boxes, and the number of units will remain same. And so this condition we also have to check. If the value of p of 1 is not equals to -1, what we will do, we'll add value of p of 1 will be equals to plus equals to value of p of 0. I think you have got this. Okay, now we have checked all the conditions. Now what we will do, we have maintained the vector. Now we'll start iterating over this maintained value vector from the 1000 index till we reach the 0th index, and we'll decrement it by 1. If the value present in the value matrix, the particular index is -1, we will continue. Else we'll check if the value present at the particular index is smaller than the total size. Then what we will do, we have our answer. We'll add I into value of I simply, and we'll decrement the total size by value of I. Simply, this is a simple case. Till this point I would be much more confident that you have got this. Okay, and at this point we'll get, we will be multiplying total size into index, and total size becomes 0. So here we will maintain the condition and the total size not equals to 0. Okay, the same condition we have in the later further approaches. So we will return answer here. This approach is taking the time complexity of order of n in the space complexity, that is constant space. So these are the 3 approaches I have told you for the question, that is today's LeetCode problem. Please share with your friends if you find it useful, and stay tuned for the further videos. Bye.